Hello, one. So we have another question from 2024 12P. So number 21. So measure of the smallest angles of three different right triangles add up to 90 degrees. And all three triangles have a side lengths that are the primitive Pythagorean triples. And then two of them are given, and we would like to find the sum of the third, like some of the sides of the third triangle. So kind of start with, I'm gonna start with a like visual. So let's say this is a 3, 4, 5. Okay, and then so I have the second one. These are not scale, but just to visually see it. Okay, so let's say this is a 3 and this is 4. So that needs to be 5. This is 5. And this is 12. That needs to be 13. So we do not know anything about this yet. So what else we have was like the smallest angles. When we add those, we are told that's 90 degrees. So in this case, 3 is the smallest side. So that side, this angle should be the smallest one. I will name this is alpha 1. The 5 is the smallest side, so which means this angle should be the smallest angle. And based on this drawing, so maybe this is the third angle. So when you add those three, we should get 90 degrees. So let's keep it in mind. So alpha 1, 2, all right. And then 3 is add up to 90 degrees. So what we can do, we can try finding alpha plus beta. If we can find that, then we can use that to get the alpha 3. Maybe that might be useful. So I can try like a lot of strict identities. In this case, like I can take the cosine of this entire sum because that is add up to 90 degrees. So I can use the double angle. Actually, I can use the angle sum for the cosine and with these three, but it will make a bit longer because as soon as I choose like alpha 1, alpha 2 as my one angle, and this is second angle, I will get 4 cos and sine values also, and then I need to expand sum of alpha 1 and alpha 2 again, which looks like it's gonna work out, but I'm not gonna do that for now at least. So what we can do instead, since we know that the sum is 90, which is really useful because when you have two angles are complementary, their sine and cosine values are equal to each other, so which we can use that. So if I take the sine of, let's say 90 minus something, let's say alpha plus beta, right? I mean alpha 1 plus alpha 2. So when you subtract this sum from 90, you actually get the sine of the third angle. So we can use that for our advantages. So let's write down. So the sine alpha 3. Okay, so when you take the sine of 90 minus something, so this became a cosine. So that should be cosine of alpha 1 plus alpha 2. And then that's just going to be same as this one. Okay, so now we can take the angle sum for cosine, so which will be equal to cosine the first angle of this one, the cosine of the first angle, and then times cosine of the second one, and then minus the sine of the first one, and then the sine of the second one. Since I know all these four because of the first two triangles, then I can find the cosine value of this one. So which let's do them. Cosine of the first one is 4/5. And then cosine of the second one is 12/13 minus the sine value of the first one is 3/5. And the sine value of the second one is going to be 5/13. So if we simplify this a bit, since the denominator will be the same, so we can keep it as 48 minus 15, so which is just 33/65. Okay, so this is what? This is our cosine alpha plus beta, right? So we can write it again. Cosine alpha 1 plus alpha 2. But this is also same as sine value of the third one, which is in this triangle. If I use this as my the sine value, so for this guy's sine will be opposite, so 33, and the hypotenuse is gonna be 65. So this is the only one that's missing. I can use the Pythagorean theorem itself and get those answers. So let's go ahead and do them. X squared plus 33, I can move that in other sides, is equal to 65 minus 33 squared. So then if I take the square root, but I will take the difference of square. So that should be 65 minus 33 times 65 plus 33. So that will be on the radical. So if I take the difference, that will be 32, right? And then that will be 98. And I know 32 has 16, so I can pull that 16 as 4. And this guy has 49 times 2, which is I can pull as 7. And then this has another 2 and another 2, which is 4, so I can pull that as 2. So that should be like 28 times 2, which is 58. And this is another Pythagorean triple, which is kind of what I expect anyway, because we are told that is the case. So if you add these guys, so you will get the 60 and 5, 50 will be 110, 140. So you got 13, another 3 is 6. I mean, no, that's going to be 13 plus 3 is 7, 54, I believe. Let me double check. So we have 56, 33 is 65. This was 65, right? So that is the case. And then we got, this is 58, so that should be 56. Okay, so if you add those, that will be 110, 121, 154. I think that's what we say. Okay, so this is one way we can use that. We just use the angle sum for sine or even cosine, right? Actually, we use cosine, and then we use some small other properties of the trig function. But instead of using this, we may also use the angle sum for tangent. So it's kind of similar. So let's try see how that looks like. So I'll pull these guys out of the way. Okay, so for the tangent, I'm gonna remember that the tangent angle sum, so A plus B, right, is equal to 10A plus 10B over 1 minus 10A times 10B. So like in this case, A and B, I'm gonna use alpha 1, alpha beta, alpha 2 and stuff. So if I take the sum of these two, so 10 alpha 1 plus alpha 2. So the tangent value of the first one, so that's 3 over 4, right? So plus the tangent of the second one is 5 over 12. So that is going to be divided by 1 minus 3 over 4 times 5 over 12. So when we simplify, denominator will be 48, denominator will be 48, so we can just cancel those. So this guy I can multiply by 3, which will be like 9. And then we have 3, 4, 5, 12. So I will see, let me double check. So that will be 3 times, that will be 9. So plus 5, 14. Actually, we don't have a common denominator. So we want to get let's cancel this first. So that should be 4. And then I can multiply this by 3. So then 9 plus 15, which is 14 over 12. And then right here we have 5 over 16. So that will be 16 over 16. So 16 minus 5 is 11. So 11 over 16. So that looks like we have 7 over 6 times 16 over 11. Cancel. That should be 8 and 3. So 56 over 33. So now we have that. As soon as we have the tangent sum of these two angles, we can use now that for our advantage, because we know that when you add those 3 angles, that is added up to 90 degrees, right? So we also know tangent, like like something, let's say theta, is equal to cosine of like 90 minus theta. So when you have two angles, I mean cotangent, not cosine. So they are equal. So since this is the tangent of the sum of two angles, like imagine there's a triangle. So let's say, actually we don't have to imagine, that's actually the case. So we know that the alpha, like 1 alpha 2 alpha 3 add up to 90 degrees. And this is alpha 3, which means the second angle in that right triangle, which is our unknown angle right here, has to be our sum of the other two angles, right? So the alpha 1 plus alpha 2. And we know that the tangent of this is given 56 over 33. So now we can use the Pythagorean, which we did already, to get the this guy. So I think it was 65. So then we are done. So if you add those, you still get the same result. We don't need this at all. We just use definition of tangent. That's it. Anyway, so there are a couple other ways I can try. Like we can even use complex numbers, but I feel like these two approaches, like we did through identities, kind of cool. So anyway, so I'll see you in the next video.